Welcome to this class, exercise 11B, Aasl, Oxford. We want to solve this question. So question number 1 says find the surface area of each figure. And that is for question A. Now we need to put some pens. Okay, so any pyramid will have a total surface area given by base area plus area of the triangles. So for this case, the base area is a square, so we'll give it by area of a square, which is side squared plus area of the four triangles, half base times height. So notice that therefore, if we do half times 4 is 2, times base, the same as the square, then times the height of one triangle each. 20 squared plus 2 multiplied by base multiplied by height, 26. 400 is the answer for the first case, and then plus this is 40 times 26, which is 1040. If we add this to, your answer should be 1440 squared centimeters. So that's for the first question. Moving on to the second question. Allow me to delete the writings of the first question. Since you can actually go back, and even if I delete this one, you'll be able to see what you have done in the previous step or previous question. So this to just give us an idea of what is happening. Okay, so this is question B. Let me give it some space. And then give it some space down here. So this is the same drill you do here. Since it's a square-based pyramid, the area will be so the surface area will be the area of the base, which is a squared, plus 2 times base times the height of one triangle. This one will be 4 squared addition, then twice the base multiplied by the height, which is 6.3. This is 8 times 6.3, and then 8 times 6.3, you get 50.4, then plus 16, you get 66.4 square centimeter. So as an HL student, especially in an AA student, make sure you go through practice doing your math mentally, and any other math that is critical, you can use your calculator or your GDC. Let's go to the next question here. The next question is question C and D. So I combine two of them. I'll use one side for C and one side for D. Let's look at how this comes about. C is a square-based pyramid. So total surface area will be given by base area plus twice base times height, which is the slanted height of the triangle. It is slanting on the pyramid, but actually it's the perpendicular to the base of the triangle. So this will be 5 squared plus 2 multiplied by, let me use dot. The dot way of doing product, 2 dot base is 5, and then height is 13. This is 10 times 13, which is 130, and 130 plus 25 gives you 155 square centimeters. 155 squared centimeters. And then for D, this is a cone square, a cone, it's a pyramid, but with a circular base. So the surface area will be given by the base area, which is a circle, then plus the area of the curved part, which is always given by pi RL. Make sure you know how to derive this formula using the concept of uh, ratios of length and area. So pi r squared, that is pi multiplied by r squared is 5 squared, plus pi multiplied by r, 5 multiplied by slanted height, which we normally call it L times 13. And then this is 25 pi plus 65 pi. So your answer ends up to be 90 pi. So that's how you get the answer. We can have that. We can always go back to the video even after I have a rest. You can always use the backward and play it slowly. Okay, let's move on to the next question. The next question should be part E. Okay, part E has two cones, which is similar to what we did in the other part. So part E, you will still have your surface area being given by base area plus the curved area, or curved surface area. So I'll shorten my calculation by doing r squared plus rl, which is 6 squared plus 6 multiplied by 14. 14 multiplied 6 is 84 plus 36. That will give you around 120. So 120 pi. Yeah, 84 plus 36. Yeah, that is 120. You can have an exact answer at this, but if they don't specify, you can always use the pi of your calculator and give your answer to 3 significant figures. So if you multiply 120 times pi, you'll get 377 squared centimeters. But if the same thing, pi r squared plus pi rl, I'll factor out my pi. R is 4 because the diameter is 8. So r squared plus r, 4 times 12. Now this is 16 plus 48. 16 plus 48, that should be 64. So your surface area should be 64 pi. So if you don't want an exact answer, you want a rounded one to 3 significant figure that is around that. So that is that. Next to our next question. Once again, not once again, I'm mentioning this for the first time. I'm using Zoom to actually do this, and I've realized I cannot move after I have done the question. It can only allow the question to be stuck on the screen. Cannot give space for the next one. So look at part A here. These are spheres, and surface area for spheres is given by 4 pi r squared, and then the volume of a sphere is given by 4 over 3 pi r cubed. So due to manipulation, paper 3 can involve the derivation of these formulas. But let's look at A. Surface area is just 4 multiplied by pi times r squared. R is 5, so r squared is 25 times 4. That should be 100. So this is 100 pi. So 100 pi, if you multiply it and leave your answer to 3 significant figure, you get 314 squared centimeters. Part B, not part B, but the volume. The volume of that is 4 over 3. Volume is equals to 4 over 3 pi r cubed. R is 5 cubed. So this is 125 times 4 is 500. divided by 3 pi. You can leave your answer as that, or if you have to leave it to three significant figure, multiply them so that you get your answer as that squared centimeters. So that is number 3. Number 2, A. Okay, so this one goes with my screen, so I'll delete and do number 3B, number 2B, sorry. So 2B requires you to do the same. So part B, surface area is given by 4 times pi times r squared. This is 9 times 4 is 36. So we are going to get our area as that, but you'll see that the 3 is not the uh, radius, it is the diameter. So we're going to multiply by half the 3, which is 1.5. 1.5 squared, 15 squared is 225. So this is 2.25 multiplied by 4. You get 9. Let me just confirm that. I don't have an online calculator. Yes, you get 9. So your total answer will be 9 pi. 9 pi, you can round it up to a rounded answer to 3 significant figure and you get that. So the volume is the same, 4/3 of pi times 1.5 cube. Use your calculator to do 4/3 times pi times 1.5 cube and you'll get 4.5 pi. This is because we have 3 1.5, so one of them will be 0.5. So you'll remain with 1.5 times 1.5 times 0.5. So if you're doing it by analytical, so 1.5 times 1.5 times 1.5, this one is 0.5. And if you multiply this and this, they just give you 2. And then this one, we said it is 2.25. So when you multiply by 4 previously, it gave us 9 pi, but now we are multiplying it with 2, so it would give us half of 9 pi, which is 4.5 pi. If you want an answer that is rounded up, you'll get this one as 14. Yeah, should be half the answer we have on this other side. So we'll have 14.1 cubic centimeters. So that is for number 2. Let's look at number 3. Always, if you have not understood how that is done, click back and return to where the video started. Number 3, we are supposed to find the volume of these figures. There are 3 of them in one. So I'm going to do part A. This is a pyramid, square-based pyramid, and the volume of a pyramid is given by a third base area, multiplied by perpendicular height, or the height above the base. So for part A, it will be a third multiplied by base area, that's a square. So for squared, multiplied by perpendicular height, which you have been given as 12. 3 will cancel out 12 to give you 4. 16 times 4 should surely give you 64. To 3 significant figures, 64.0 squared, cube centimeters. So for part B, volume will be given by the same formula. Base area is a triangle, so area of a triangle is a half base, 10 times height, 13.077, 10 times perpendicular height, which is 11. Use your calculator to do this, and this will surely give you 240 cubic centimeters. Once you use your calculator, you'll be able to get that. And then for part C, let me do part C here. The same drill we are doing. A third volume is a third, base area is 9 multiplied 7 times height, which is 5 perpendicular height. So 3 goes to here, 3. 3 times 7 is 21, and 21 times 5 is 105 squared, cubic centimeter. So those are the volumes of those ABC. And then we are going to check the volume, the next question. And let me put a mouse. So one way to score, highly score in IB, so first write the formula if you're not sure, and then substitute, work out, you can use diagrams and so forth. So find the curved surface area, the total surface area, and the volume of the cone. So curved surface area will have the formula of pi RL. L is the slanted height of this cone. And because this is a right angled triangle, the base, the radius surely meets the line directly above it. It's perpendicular. That theorem should look at it. Then, since this one is right angle, we'll use Pythagoras theorem. And if we call this one L, we will say L squared is given by 12 squared plus 5 squared. This is 144 plus 25. This is 169. You do the square root, you get L as 13. So this one will be pi times R times 13. This will surely give you 65 pi. Or if you want to round it, give it some three significant figures, it means you should have a constant gone. So 65 times pi will give you approximately that answer. Let me do part B that says total surface area. So if this is a solid cone, we will have the total surface area being the area of the base, which is a circle, plus the curved surface area. So the base will be pi multiplied by r squared, then plus 65 pi. I'm using the exact value so that I minimize errors or accuracy. I be more accurate. So 5 squared is 25 times pi is 25 pi plus 65 pi. This one will give us 90 pi. You can always put it into three significant figures and you'll have that. Lastly, they're asking for the volume. Remember, the volume is given by 1/3 base area, which is circle pi r squared L times the height. This is not L, is H. H is this height, so we'll use that height because that is what describes the capacity or the volume, the space occupied by the cone from the ground or from the base. A third pi, or it gives us a better orientation in short. A third pi times r squared times h is 12. So if you do this, you'll get your answer as 4 times 25 is 100. So 100 pi, which is the same as 314 cubic centimeter. That's how you do number 4. We can look at number 5 and the rest. So let me put a mouse, go down, and let's attempt number 5. Number 5 asks you to find the curved surface area. So this is an hemisphere, and curved surface area will be the area of this part only. So the area of this part, when it is in totality, the whole sphere, the area is given by 4 pi r squared. But if it is an hemisphere, area of hemisphere, it will be given by half this, which is 2 pi r squared. Okay, so 2 multiplied by pi, radius is 3. So you get your answer as 9 times 2, which is 18. So 18 pi, if you are told to three significant figures, should have something like 56.5 square centimeters. Just multiply 18 times pi in your calculator. Part B, total surface area. Total surface area means the curved area plus the area of this circle. We have the curved surface area already. So the area of that circle will be given by pi r squared and then plus the 2 pi r squared for curved. So we only need to calculate this, which is pi times 3 squared, then plus our 18 pi we got. This should be 9 pi plus 18 pi, giving you 27 pi. 27 pi to 3 significant figure is 84.8. Just quickly did my calculation here with the calculator, and we get that. Lastly, we need to look at the volume of the hemisphere. Allow me to erase so that I can do the volume. So volume will be given by the volume of a sphere is 4/3 pi r cubed, but because this is half the sphere, you divide this by 2, which will be ideally be 2/3 pi r cubed. So 2/3 pi times r cubed. This is 27 divided by 3 is 9, multiplied by 2 is 18. So here we have our answer 18 pi to 3 significant figure, that is 56.6 cubic centimeters. So that is for number 5. Let's move on to number 6. We put a mouse. So number 6 tells you to calculate this. Benji has an ice cream cone. The ice cream is in the shape of an hemisphere sitting on top of a cone. What is the volume of the ice cream cone? So all these ice cream cone, its volume will be given by volume of the cone, this cone at the bottom, plus the volume of the hemisphere. This is a sphere. If it will be in its totality, it will be a sphere because it's half, it's an hemisphere. And they have said it's an hemisphere there. So the whole ice cream cone is made up of the cone plus the hemisphere. So that's why we are adding the volume. The volume of a cone, we said it is given by 1/3 pi times r squared multiplied by L, h, perpendicular height 10. And then we add the volume of an hemisphere is 2/3 pi r cubed, so 4 cubed. So let's simplify. Here we'll have 160 divided by 3 pi plus 4 raised to 3, 64 times 2 is 128. 128 divided by 3 pi. So if you add this and give the answer to 3 significant figure, is 302 cubic centimeters. That's good. Then number B, so for you to get the surface area will have you to calculate the area of the curved part plus the area of the curved part of hemisphere. So curved part, but this one is hemisphere. This is curved part cone. This is curved part hemisphere. Curved part cone will be given by pi RL, so pi RL. L is this slanted height. So because this is 90 degrees and we're using Pythagoras theorem, this slanted height will be 10 squared plus 4 squared. So 100 plus 16, which is square root of 116. I'm going to write the exact value, square root of 116 for accuracy purposes. Curved, so pi RL is correct. Then curved part of hemisphere is, we will calculate the area of this curved part, which will be pi R squared. Let me just confirm that the area of an hemisphere, the curved part is that. So we will have pi 2 pi r squared. That is the volume of a hemisphere. So 2 times pi times r squared, which is 4 squared. So if it was a sphere, it was 4 pi r squared. And hemisphere is 2 pi. r squared. So this is pi times 4 times 1 square root of 116 plus 16 times 2 is 32 pi. Give your answer to three significant figures. Do that and you get your answers 236 squared centimeters. Just confirm that. Sorry for some confusion on the area of an hemisphere. It's half the sphere. Okay, with that, let's move. Let's move to the next question, which is question 7. Okay, question 7 says that a water tank is in the shape of a cone sitting on top of a cylinder. How many liters of water can it contain? So here we will be calculating what we call capacity. So after we have calculated, because we can calculate the volume, we can convert the volume to capacity. So what is the volume of this total figure? So the volume will be given by volume of cylinder plus volume of cone. So the volume of a cylinder is given by pi r squared times h. Volume of a cone is given by 1/3 pi r squared h. So we see pi r squared h is common to both, but the h for this case is different. For the cylinder will have capital H, then this one will have small h. Radius is the same, so r squared, r is 1, so 1 squared times h, capital H, from here to here. So from here to up here is 13, but from here to here is 2. So we are going to subtract. So ideally, you'll see that for you to reach 13 and you already covered 2, you will need 11. So 1 squared times 11, then plus 1/3 times pi times r squared again, 1 squared times the height of the cone, which is 2. So this one will give you 11 pi plus this one is 2/3 pi. Add these two and you'll surely get 36.7 cubic centimeters. It's a significant figure. So the capacity in terms of liters, the conversion is 1 liter is 1 liter is equivalent to how many centimeters cubic? Let me just use my conversion to convert that. Yeah, so this one will be 36,700. 36,700. 36,700. This is not centimeters. This is cubic meters. And that's why we use this, we use the conversion that 1 cubic meter is 1,000 liters. So what about 36.7 cubic meter? And you get it in liters at that. So that should be your answer for number 7. You can always go back and see what you have done. Then number 8, which is our last question. So cylinder can hold cylindrical can hold 3 tennis balls. Each ball has a diameter of 6, which is the same diameter as the interior of the cylinder, and the cylinder is filled to the top. How much space in the cylinder is not taken up by the tennis ball? So for this kind of a question, it's good to have a model of it. So this is the cylinder, and let's say the top is covered. and we'll have 3 balls up to the top, which are similar. So let's assume these 3 balls are similar, though mine one looks bigger than the other. So they're asking for the space not occupied by the cylinder, or not occupied by the balls. So the space will be given by the volume of the whole cylinder, subtract the volume the 3 balls have occupied, the volume of the 3 balls. So we have 3 balls, 1, 2, 3, they have occupied some volume, and then we have the cylinder, but they have left some spaces here, and that's what you are calculating. So volume of a cylinder is given by pi r squared h. Remember, this diameter is the same for the cylinder, so the radius will be 3. The diameter for each ball here is 6. So we'll have 3 sixes, which makes 18 centimeters as the height. So volume of the cylinder now is pi times r squared times height, and then minus volume of the 3 balls. Remember, the 3 balls are a sphere in nature. So the volume of a sphere will be 4/3 pi r cubed. So, and because we have 3, we have to multiply them by 3 r cubed. So this one will go with this. And then here we will have 18 times 9. So 18 times 9 is 162 pi, minus this is 27 times 4. 27 times 4 is 2802, 108 pi. Let me just confirm that. 27 by 4, 82, 10, yeah, 108. Subtract these two and you'll get your answer as 54 pi. The 3 significant figure should be 170 cubic centimeters. So that is exercise 11B. Tune yourself up for the next exercise. See you.